G.
Yep.
So it would be positive from A to G, but not including either.
Oh, positive, yeah, so it's positive as long as it's to the right of that, so A to G, but not including, correct? So we established 0 is A and G, but not including. Or positive, but not including. All right, and where's it negative?
I and H.
Yes, that is correct. That's not complete though. What you said, if you wrote that down on a piece of paper, you basically just said those two.
So it's the I, through H, no,
What would be negative?
Where is it negative?
it'll be negative from the I to the F.
Not the F. Remember, the starting point is here. This is my starting point.
Okay, okay.
And I know I'm a little slow, but displacement has SP, like starting point, right in the name. Anyway,
It would be I and H.
It'll just be between the I and the H, not including the I and
It would be I and H.
it would include I and H and in between. What, that part is correct, but we've left something out. All right, so we got in between. What about G to H? The advantage of this format over here is that there's clearly something missing. What's happening between G and H?
Negative.
It's
Behind the starting point.
Yeah, it's to the left of the starting point.
I was just about to say, it's starting to turn, but I'm like, no, wait, I can't use the word turn. But,
I guess,
yeah,
I would not have used that word, yeah.
that's right, the same thing.
And notice also it's going from positive to negative, but by passing through 0, which is gonna have to do. And up here goes from negative to positive, passing through 0, and then back to negative, but passes through 0.
On these problems, are we gonna be giving a starting point? Cause
Oh, yes.
I wouldn't have known it if you hadn't.
Oh, no, it's stated out there.
Okay.
A is, let me just tell you now, A is the starting, it's the time of the starting of the problem. All right. Velocity. Let's identify first, where's the velocity 0?
G. G.
Not G.
C.
You said G as in giraffe?
You're
Okay.
right.
Yeah, not G.
This, C is the starting point? That's what it was like, no.
I'm asking where's the velocity 0? This is asking where is it stopped?
E and C? E and C, cause it's on 0.
No, that's 0, that's just a location. That's a position. That's not telling you how fast it's going. There's one of them.
D.
Yes, I and D. It stops. The thing is moving along here, goes up the ramp, stops, comes back, and then stops here. So velocity is 0 at D and I.
I think you can't see the like all the little directions he wrote out. That might be what it is.
No, I can see it. Thank you. I just didn't look at it.
What's the diagram supposed to be of again? Is it like a box moving?
Yes. Oh, I apologize.
Yeah.
So we basically have this, the line right here is basically, think of it as a floor or a gutter. You know, I've got a slope here, flat area, and then a slope here. There's a box that starts out at this point right here, already moving to the right by the time we start the problem. Goes to the right, goes up the ramp, and then comes back, and then goes up the other side and stops. And it will then slide back down, but that's after the problem. Now I have the letters A, B, and C down here, not saying that the box is underneath this, just trying to keep it a little bit decluttered. That it's going to the right at these times and coming back at these times. But it's on top of this gutter or whatever it is, this strange floor, moving that way and then back to here. Usually there's a paragraph of description about what's going on. Please make sure you read the paragraph and not just skip to the problem, because the paragraph is generally where I slide in where the origin is. All right, any other questions up to here?
Why is the, positive distance A to G instead of like A, G, and then G to E?
All right, these are moments in time, so if you think about a stopwatch, that this object, you start the stopwatch here, it moves with time, and so the letters work in, the alphabetical order is the same as in progression of time. So, when you said, the language was a little bit off, we talked about the displacement being positive just after it starts, until it gets back to where it was when it started. So that's why we're doing A to G, so A, B, C, D, E, F, G, it's on the right side of the starting point. Other questions before we tackle velocity being positive and negative? All right, where is the velocity positive?
E and D,
E and D,
or,
no, D is 0.
okay, so E,
Which way is the box going at E? At time E, which way is the box going?
Down.
oh, yeah, it's starting to go up a little.
Not at E. At C, it's starting to go up. Just after C.
I know that.
E is on the way trip,
Yeah,
just the trip back.
yeah, okay.
So the box, yes, box movement,
Mm-hmm,
box.
down, okay. So then so maybe at C,
It is definitely positive at C, so I'll put a little plus sign right there.
Great. A to B.
Did you want to include A and B in that? Or just in between?
Yes. From
How about
to
B
F.
to C,
E to C,
C to
C
D?
to D.
Remember, in order to go from positive to negative, it has to pass through 0. If we've correctly identified where 0 is, once you've identified one of these as positive, all the rest have to be positive, unless we've made a mistake somewhere. But it is positive as long as it's going in the positive direction. That's from the beginning of the problem until it stops. A to D, not including D because D is 0. And then negative,
The rest?
other than I. Yeah, I guess the rest. So D to I, not including them, so negative, negative, negative.
When you do it this way, it kind of makes sense, especially with like the full drawn out chart. But I feel like on the test, I'm not gonna have you right there, and it's not gonna make as much sense.
Yeah, you know, do the best you can. Which I'm sure brings great comfort. All right, acceleration, here's the tough one. Erica.
I'll leave it at the
Now, this notation right here, I mentioned it down here. Last moment of friction. This is shorthand notation for the fact that the friction is not 0. This symbol right here is the letter mu. In chapter 4 or 5, we'll talk about this in more detail, so by the time the first test would roll around, you would have seen this. But this is just saying I have friction in this region right here. There's friction in this region. And friction opposes the desired motion. So when the box is sliding to the right, so from A to B, which way is friction acting on the box?
Left.
When the box is falling to the left here from F to H, which way is friction acting on the box?
Right.
Okay, that becomes critical. All right, so from A to B, the friction on it is to the left, it's slowing it down. So my acceleration is negative in that first region right there.
Friction goes against acceleration, always?
No, friction goes against, is opposing the relative motion, relative velocity.
Have a good one.
So in this region right here, also notice my velocity and acceleration are different signs, which means it's slowing down. And when the box is moving to the right, it's slowing down because of friction. If we did the full force diagram of it, from A to B, we have weight acting down, we have normal force acting up, and we have friction acting back. There's no force to the right acting on it, because whatever is propelling it to the right, we don't know what it is, and it doesn't matter. Motion has no memory, it doesn't care about what happened before. And some things do come into existence already moving. Things do not automatically necessarily start at rest. All right. From B to C, there's no friction acting on it. Is anything slowing it down or speeding it up in this region right here? Therefore, what's the acceleration? I would quibble with nothing versus 0, but it is 0. Once it gets to the ramp, the box is now moving up the ramp. Is it speeding up or slowing down?
Slowing down.
I hope so. And if you've got a box to slide up a ramp and speed up without any other additional force acting on it, the government will want to have a conversation with you, and you'll never be heard from again as you work on weapons. All physics leads to weapons, honestly. All right, so as this is moving up, it's slowing down. So my velocity is positive, so it's going to be negative there. My acceleration would be negative. At D, it stops, then turns around. Which way is the force acting on it at this point?
Positive.
So it's being forced to the, in essence, sort of up the ramp.
No, it's negative, because it's going down.
It's about to go down. So it slows down, stops, and comes back, similar to the ball being thrown into the air. The acceleration was negative the entire time. Then it slides back down until it gets to E. As it's sliding down, it's speeding up, which means velocity and acceleration are the same sign. Or, if we did a force diagram here, there's no friction involved. I have weight acting down and normal force acting this way. There's no force acting up the ramp. Once it gets to E, it's on the flat level surface again, until it gets to F. Once it hits F, which way is friction acting on it?
Right.
Therefore, what is the acceleration, positive or negative? There was a big question mark at the end of that. Say it again with great confidence.
Positive, because its velocity is negative and it's opposite. It's like-
Oh, that's one way of looking at it, yeah. Or the total, the net force acting on it is to the right.
Yeah.
So it's positive, 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 till we get to H. H is the last moment it's touching the friction. Last moment of friction. And now it gets to this ramp. As it slides up the ramp, speeding up or slowing down.
Slowing down.
My signs are opposite. And then I is a turnaround point. We stopped the problem at that point. If we kept it going, it would hit I and then started sliding back down again, because there's no friction on the ramp to actually stop it permanently. So for the same reason that the acceleration is negative at point B, the acceleration is positive at time I. So, and this one starts to get a little cluttered, but it's 0 from B to C, not including B, but including C. And E to F, not including F. It is positive from F through I. And then negative A to B. And then C to E, not including C. Give people a moment to write stuff down and ask questions. We're gonna look at the acceleration a slightly different way in just a moment that some people find helpful. Becca, you have a question?
Is that, A to B under the negative one?
Yes, A to B is negative.
Okay, I just couldn't really read it.
Yeah, that. Yeah, that's so much better.
Okay.
Now, if this is like the typical class, there's gonna be at least one person for every format. Somebody is gonna do this one, and that's not a problem. Please make sure I can tell the difference between your brackets and parentheses. Sometimes I get I'm going, it looks like there's an angle there, but I'm not 100% sure. Like,
Can you explain why for acceleration, point D, it was negative? Again, instead of it being like 0
Right.
and nothing?
so once it gets on the ramp, there are only two forces acting on it. The weight is pulling down on it, and normal force is keeping it from going through the ramp.
Mhm.
If I add those two forces together,
Put the bracket around B.
I have normal force going off that way, and I have weight acting down. The net force acting on it, adding vectors from where I started to where I ended, the net force is down the ramp, which is the negative direction.
Okay.
Is that sufficient? There are other ways that I could do that. You want me to do it
Do
a
it
different way?
another way.
All right, another way of looking at it, and I am gonna do another way in just a moment, that potentially will help, is I know it's not 0. Is your gut telling you it's 0 or gut telling you that it's
I
positive?
feel like it's 0 because that's like, in my mind, it's like that's the turning point, like it stops and then it goes down.
Oh, it does stop, absolutely,
Okay.
but the velocity still changes.
Okay.
If the velocity didn't change, if acceleration is 0, that says the velocity is not changing. And since it stops here, if the velocity didn't change, it's not gonna slide. It's gonna get up there and stop,
Oh, okay.
and stay there. So that's an argument against it being 0.
Okay. It's still in motion, even though it stopped for like a brief second, it's still in motion.
It depends on how you want to define motion. Sorry, I didn't want to get the semantics of it, but the velocity is still changing.
Okay.
I don't suppose you've had calculus. Have you? Like,
Pre-calculus,
pre-calculus? Are you doing that now or have had it?
dropped it.
Fair enough.
Did you get far enough to start doing slopes of curves?
Mhm.
All right. Obviously, not for everyone. For those who understand it, great. If I throw an object up into the air, let's see, 0.4. So if I look at displacement versus time, if I throw something in the air, it's basically going to look like that. If I looked at velocity versus time, because remember, velocity is the change in position over change in time. Well, if I'm looking at this graph right here, this is my rise and my run, rise over run. So this is just the slope of that. At this point right here, the slope is 0. My velocity is positive, becoming less positive, 0, becoming more negative. That's basically what it looks like. Velocity is 0 for just a brief moment, but it's constantly changing. If I then look at acceleration versus time, well, acceleration is the change in velocity over change in time. Well, if I'm looking at my velocity time graph, that's my rise over my run. This is just the slope of that. my slope is negative the entire time.
Gotcha. So-
Just a different way of looking at it.
Okay.
Now, if you haven't gotten that far in math, or it's been too long, relax. But if you understood it and it helped you, zang. Right, any other questions before we look at this a slightly different way? Alright. I want a different color, or at least something bold. It's time, if I can get into it. I don't have green over there, we shall do green, and hope that this works. That is not particularly spectacular. All right, I'm just gonna make up numbers here. I know that I'm gonna write down velocities at these various points, just taking into account the stuff that we know. So I'm gonna start out with 20 meters per second, just because I've actually did something similar to this earlier today, and 20 seems to work. If you pick a different numbers, you know, you can always force numbers how you like them. So this is 20 meters per second, and that is staggeringly underwhelming. What are the chances it'll like this one better? From A to B, it's slowing down. It's going over friction, so it's slowing down, and so I'm gonna say that's going 15 meters per second. So it starts at 20 and goes to 15. Then it reaches this part of the floor here where it's not changing anything. There's no force that's causing it to change its velocity. So it's still going 15 meters per second by the time it gets to its point C. It's then gonna go up the ramp. It's gonna stop here. Then it's gonna slide back down. And at point E, because there's no friction involved, as we'll discuss chapter 7, it'll be going negative 15 meters per second when it gets to time E. So it's just the same speed as time C, just the other direction. At point F, it's still going negative 15. Now it starts to slow down. At point G, let's see, it's slowed down, so it's now going negative 10. It's still slowing down because I still have friction